Okay. This is an afternoon. Good afternoon, family and friends. Um, for those that are tuning in for the first time, my name is Mr. Mlenga. I just yesterday I uploaded a video where I was talking about the acid bases and salts. In particular, I was talking about what salts are. Today, I want us to discuss with you on the subject called mensuration in mathematics. So, today I'll be looking at mensuration. There are quite a number of things that are involved in the mensuration topic, but today I just want to assist ourselves into the volume of shapes. And these shapes that we're going to look at are the cones as well as the prism. But now the prism, the cone is something that we know. Many of you have bought a cone ice cream before. Now that package, that cone, the one that you hold, that's the shape that we'll be looking at how we can find the volume, the amount of space that such a shape can occupy. Then a prism, a cone looks like this. It can be, you can have the tip on top there, and then the base is always circular. That is a cone. Yeah. So this is a cone. This is a cone. And this one, so this cone here has got the perpendicular distance up to the center of the circle. So this is the radius, this is the height, and this is the slant length. So this is what a cone looks like. So we're going to look at how we can find the volume of such a cone. Then from there, we'll also go as far as looking at how we can find the volume of a prism. But now, prisms are in different types. Most of the times, the type of a prism is determined by the shape of the base. If the shape of the base is a rectangle, it is called a rectangular prism. If the shape of the base is a triangle, it's called a triangular prism. So today the type of the prisms that we're going to look at is the either the rectangular or it has got a base which is a circle. But I want us to start with the a cone. How do you find the volume of a cone? Volume of a cone. Now, in most cases, if not always I would say the formula for finding the volume of an item, it's always the base area times the height. So when you have a cone like the way I'd drawn it, when you have a cone like the way I'd drawn it, we have a cone of this nature, where we have this has a height and this has radius, height, and L. So finding the volume of such a cone, volume is equal to base area times the height. Now, if this cone here, if the shape of the base had to go all the way up to here, if the shape of the base was also the same shape that is on top here, this the formula for if this was the size of the base, if the size of the base was the same as the size of the top, the formula could have been, you look at the base is a circle. So the area of the circle is pi r squared. pi r squared. Then times the height, which is going to be pi r squared h. But because what we have at the bottom is not the same as what we have on top, this area here is not here. This area here and this area here on the cone is not there. So to cater for that space, we're going to divide by 3. So that is a formula that we use to find the volume of a cone, which can also be simplified as V is equal to 1 over 3 times pi r squared h. That is the formula that we use to find the volume of a cone. So let's see, go to the example. I have made a single example here that we're going to look at as we get to look at uh, the the cones and then we get to the prism. Um, Now, the example that we're going to look at is very simple. Always the first thing gets simple, then as we get to second, third, then there are more things that are added. So if you look at this cone, the question goes like, find the volume of a cone. Find the volume of the cone. Find the volume of the cone. Find the volume of the cone. But the radius here, the radius that we have been given that the radius is 7 centimeter. The height is 10 centimeter. Then the slant length is 5 centimeter. So we are told that the slant length is 5 centimeter, the radius is 7 centimeter, the height there is 10 centimeter. Now, how can we find the volume? Like I'd said, that the volume of a cone is base area times height. So we're going to do this together. So I'm going to say volume is equal to pi r squared h over 3, provided we take the pi to be 3.142. By the way, that pi is constant, it's always given. It's either they give you 3.142 or they give you 22 over 7. 22 over 7 is a complete number. That one has just been rounded off to 4 significant figures. Now, if you look at this information that we're given, what is the pi? The pi is 3.142 times, what is our radius? Our radius is 7 here, but the radius is squared. So we're going to square that 7, then multiply by the height is 10. Divide by 3. That is the formula we're going to use. Then we say, what is 3.142? We're going to say 3.142 times 7 times 7 times 10 to give us 1,539.858. That is divided by 3. So once you multiply 3.142 times 7 times 7 times 10, it gets us 1539.58. Then we divide by this 3. And once that is divided, so that answer divided by 3, we're going to have 513.19 centimeter cubed. So that is the volume of the cone. So always, whenever you are taught to find the volume of a cone, it's base area times height, but we have to divide by 3. That's what the formula tells us. So 3.142 times 7 times 7 times 10, then we divide by 3. But in most cases, when the question comes in an examination, most of the times they remove the top part of the cone, something like that. They'll give you that. They will remove the top part of the cone, maybe like this. They'll just give that. when they ask to find the volume of a cone. So when such a question comes, we have to make sure that you extend the line to assume that the cone is complete. Then you're going to find the volume of the complete cone. We subtract the volume of the cone that is removed. Most of the times, that is how questions come in an exam. Now, when such a question comes, we combine this concept with another concept which is borrowed from congruent and similarities. Congruent and similarities is a topic that is linked to this when you are told to find the volume of a sliced cone, because I'll explain this later. So maybe if you can allow me to pick on one of the past paper question which contains the volume of the cone, so that here we are going to see how we can play around that. How can we find the volume of a cone when it is halfway sliced? So I'm going to pick on any question that I'll find, then we see how we can locate the volume of a sliced cone. Remember, we are looking at the volume of a cone. Just allow me to have this. But before I go to the question, let me give you a certain reminder. Like I had said, when you have a cone like this, if this is your cone, okay? If this is your cone like that, whose features, this is the radius, this is the height, and this is the L. So now if this cone was sliced from the top, if this top part was removed, this top was removed, we're going to have this figure having the top part in hidden details. Okay, we're going to assume that this was a complete cone. But this complete cone and the cone which was removed, we're going to have two radii. We're going to have this radius of a big cone and the radius of the cone that was removed. So we're going to have two radii. Now, to put a clear-cut distinct between these two radii, we're going to have one, the R, big R, representing the big radius, and the small r representing the radius of the small cone, which is removed. Take note of that. Okay, so we're going to have this r here and the small r here. Then the other thing is, if that is done, we're going to have another height for a smaller cone. Okay, so we're going to have two heights. So as for the height of a complete cone, we are going to call it h. Then the height of a small cone will be small h. Yeah. But now, if this is the cone that we have, this is a detailed structure of a cone that we have. If we are going to, if you are allowed to remove this part, if you allow me to remove this part, just that part, just that part, just that part. If you remove that part, we'll end up having something like that. We end up having something like that. We end up having something like that, where this brush here is representing the big R, the radius of the big cone. Then this line here is representing the radius of a small cone. The distance from here up to here is representing the capital H. This distance here is representing the capital H. And then the distance from here up to here is representing the small h. Yeah, that is how you can extract it. Now, I remember saying whenever they ask to find the volume of a cone, when the certain part is removed, we combine the concept of congruent and similarities. What does it state? If this shape, this area here, if this shape here, see that shape, if this shape is similar to that shape, if the small triangle which is on top is similar to the big triangle, we say if two or more shapes are similar, there are certain conditions that are followed. If two or more shapes are similar, one, we say that the ratio the ratio of their corresponding sides, the ratio of their corresponding sides is the same or is equal. The ratios of their corresponding sides is equal. The ratios, the ratio of their corresponding sides is equal. So what do I mean? Meaning the ratio of the corresponding side of this small radius here in the top triangle is this radius that is here. So if this triangle is similar to that triangle, then the ratio of that line to that line must be the same as the ratio of the small height to the ratio of the bigger height. The ratio of their corresponding sides must be equal. Then the other condition that we combine here is that if these shapes are similar, then the ratio of their volumes or the ratio of their surface area, the ratio must be not the distance. The distances, my dimensions may not be the same and cannot be equal always, but we're talking about the ratio. Take note of that. So the ratio of their corresponding sides is equal. Then the other point is that the ratio of their volume or surface area surface areas is equal. So these are the two conditions that must be met if we say that two shapes are similar. If two shapes are similar, the ratio of their corresponding sides must be the same, and the ratio of their volumes must be, or their surface areas must be the same. What practical example can I give? When, like my uncle told me that I resemble my dad in some ways. The resemblance there, the similarities between two people must be attained or must be explained in terms of corresponding features. They cannot say my nose looks like my dad's toy, because my nose and dad's toy, they are not corresponding organs. So when you talk about similarities, you talk about corresponding items. That's why I'm saying the corresponding sides. So you cannot compare the ratio of the side and the ratio of their volume. No, you cannot say, your nose looks like your dad's shoes. You can't say that because those are not corresponding items. So this is a very, very important concept that we're going to have. Now, if this is linked to that, what can we say? The small r over the capital R, because these are corresponding sides, must be the same as the small h over capital H. This is the concept we're going to borrow from similarities and congruence. Small r over big R must be the same as the small height over the big height. Just that is all it takes for you to answer a question that comes from the volume of a cone. So now let's look at some of the past paper questions that have been asked so far. How can we apply that concept gotten from congruent and similarities? How can we compile the two concepts, one from the volume of a cone, mensuration, and the congruent and similarities? How can we compile these two ideas? That will be our next point of discussion. Now, allow me to pick on this question that came in 2017 GCE. The question may not, I'll just indicate the year to avoid writing here. I'll just indicate the year and I'll write the diagram so that if you want to go through the question, you can just go to the past paper, which I'm going to indicate here, and then you get to have it found. So most of the times, the way I indicate these questions, I'll put the subject code because this math is 4021, so that is mathematics. code, then I'll put stroke 1. Why? Because stroke 2. Why 2? Because this is paper 2. If it's not clear, I can rewrite it. So this 41, 21, 40, 21, then stroke 2, stroke 20. I said this came in 2017, stroke GCE. That's most of the times how I write questions. I don't write for questions, I'll just link you to the question. So that is a 4021, that is a math subject code, paper 2, 2017, and that is GCE. Now, the way the question came was like this. There was a cone. Okay, this is how the question is. You can look up for the question in that indicated past paper. Then we have the top circle like that. The radius down here was 12 centimeter. Okay, then the distance from here up to here was is 15 centimeter. Okay, up to here. Then the small the radius on top, the space is not enough, so they just said, okay, so this was C, then this is C, this is B, this is X, and this is, okay, there is that. This is E, and then this is Y. So they said that point EX, given that EX is equal to 4 centimeter, the space here for them to indicate a 4 centimeter was not enough. So that's why they just gave that extra information that EX is equal to 4 centimeter. Then the question goes like, okay, blah, blah, blah. There's enough of information which you're going to find. But the question that I need is saying, calculate the height AE. So here, that's where we've got our A. Calculate this height. We're talking about the height of a cone that was removed. Talking about the height of the cone that was removed. But now, if you look at the way that question is, it's not too far from what we know. It's not really too far from what we know. So there, what we're going to do is we look at the correspondence in terms of sides. The correspondence in terms of sides. So what can we say? We are going to divide this cone into two, like that. So once you divide the cone into two, we'll end up having the markers I have also almost done. Once we divide that into two, we are going to have that. Jesus Christ, one is completely done. Okay, so we are going to have two shapes like that. Hope you are following. We're going to have two shapes like that. If when taken to the other side, we are going to have this. That is a shape we're going to extract, where this is our E, this is our X, this is our A, and then down there, is there any number that is indicated that I might have forgotten? Oh, this is DS. Okay, so this is D, and this is B, where DB is 12, DED is 15, and then here is 4 centimeter. You see how we can extract the information right from here. So from that, now it becomes easier for us to play a mathematical game. So we are going to say that this EX, which is representing a small r, then D is representing the big R. AD is representing the capital H, then AE is representing a small h. So we are going to say that according to the similarities and congruence, we are going to say that small r. But by the way, do you know that this 15 is on from E up to D? So what then we're going to have the small h here, then this small h is just from A up to E. E up to D, that is 15. So our big H will be found by adding the small h here plus the 15. So that's our big H. Where there's a big H, supposed to put H plus 15. Why? Because this is a small h for the cone that was removed. Then this is 15 for the remaining part. So finding the total height, we're going to add the h plus the 15. That's why I have indicated it like that. So what are we going to say? We are saying small r over big R must be the same as small h over the big H. But remember the H, where there's a small height, where there's a big height, we're going to put that. So we're going to have the small r is 4. Small r is 4 over the big R is 12, which is equal to the h, small h we don't know. The big H is h plus c 15. Then from here, if you want, you can even reduce it. You see that the 12, 4 can go into 4, 1, 4 can 2 go into 12, which is 3. If you want, you can reduce, which if you do that, maybe if you can allow me to use a different color, if you do that, you're going to say 4 into 4, 1, 4 into 12, which is 3. And once that happens, you're going to have 1 over 3 equal to h over h plus c 15. Then once you cross multiply 1 times h, it's h plus 1 times 15, which is 15, equal to 3 times h, which is 3h. But you and I know very well that these are unlike terms. You can't do nothing with them. So the only thing that you can do is let this guy go there. So once this guy goes there, we're going to have 15 is equal to 3h minus h. Okay, once that happens, we're going to have 15 is equal to 2h. But we are told to find the h, so here you divide by 2, you divide by 2, so that you're going to have h is equal to 15, divide by, 15 divided by 2, so the small h will be 7.5. That is the small height, which they have told us to find. So the small height there is, if you can allow me to go through, I said this radius here over the big radius, because these are corresponding sides. We're saying the ratio. When they say the ratio of 1 to 2, you can also write at 1 over, and this is what I did here. So then the small height over the big height, but I said the big height is a combination of a small height plus the 15, which is given, and that's why I went that way. So once that is substituted, we have 4 here, then 12, small h plus 15, which is standing for the big H there. Then here divided 4 into 4, 1, 4 into 12, that is 3. So I have 1 over 3 equal to h over h plus 15. I just got it down here. Then I cross multiply 1 times h, it's h plus 1 times 15, got me 15. Then here also cross multiplied 3 times h, 3h. These are like terms, you can do nothing with them. So I had to collect like terms that went there, then I had 15 remaining. This side is equal to 15. This is positive, it gets there, minus h. 1h minus 3h is 2h. We are finding the value of h, divide by 2, divide by 2. That is 2 into 15, which is 7.5. That is the question they told us to find the small h. So once you have the small h, finding the big H, it's not an issue, because say the big H is 7.5, 7.5 plus 15, and that will give us 22.5 as the big height. As simple as that. So once that is done, then we go to the second question. What is the second question saying? The second question is saying calculate the volume x, y, c, b. Say x, b, cy is the volume of the cone that remained. However, the question there is very simple. We just need to go back to the information that we were given at first. What did I say? I said the volume of a cone is equal to, or is given by, the pi, the base area times the height. but we're saying the base area. So what is the shape of the base? The shape of the base is a circle. So how do you find the area of the circle? The area of the circle is pi r squared. Then we multiply with the h. But you also have to divide it by 3. Now, there are few things that I have to remind you from what I have rubbed. I said this, we just found that the small h is equal to 7.5, then the big H is equal to 15 plus 7.5, which gave us 22.5. Then the small r is equal to 4, the big R is equal to 12. So this is what we need. Now, once you have that, it's a quite long question because even the marks, they give about 6 marks. 6 marks when you see that the magnitude of the marks. It's not something that you can just get within a fraction of a second. So we're going to say that the volume is equal to the volume of a big cone minus the volume of a small cone. But the volume of a big cone is pi r squared, because a big cone, so I'm going to use big letters, divide by 3 minus the pi r small r h over 3. But you can see that pi over 3 here, pi over 3 here. It's common. We cannot say the radius, a big radius and a small radius are the same. Small radius is 4, big one is 12. So we cannot substitute. So because these guys are common, we're going to take them out. And once you do that, you're going to have pi over 3 outside, then inside r squared, h minus r squared h. So that is the formula that we're going to use. Then from there, we just substitute. What is a pi? Is 3.142 divided by 3 outside. Then inside, the big radius is 12 squared times the height is 22.5 minus the small radius is 7.5 squared, and then times the small, this is, oh, sorry, the radius is 4. So the radius here is 4. So I'm going to say 4 squared times this 7.5, like that. And once we do that, when you divide these ones here, if you divide that 3.142 divide by 3, will get us a very big number. Okay, let's ignore that. Just say 3.142 divided by 3. Then inside 12, let's go and say 12 squared, and go and say 12 times 12, and then times 22.5. Okay, that will give me 3240 minus, there is 4 by 4 by 7.5, and that gives me 120. 120. Once I subtract this, I'm going to have 3.142 over 3 times. Once I subtract the 2, so I'll have 3240 minus 120, and that will be 3120. 3120. So when you multiply this, then you divide by 3, you're going to have 3.142 times 3120. The answer divided by 3 is going to be, so the volume of the cone is 3267.68 cubic centimeters. So that is the volume of the cone. And that is how we can find it. Now, can I remind you again? We are saying the volume is V2 minus V1. V2 minus V1. The V2, the formula for V1 and the V2 is the same. V2 and V1 is the same, but except that the parameters are different. For this big or complete cone, we are going to use big block letters, radius, a big R. h, the big height. But we know that our h is 15 plus 7.5 is 22.5. Divide by 3. Minus, we remove the one which is on top, pi r squared, the r small, and the small h, divide by 3. But I said that this one here, if I can allow me to use a different color, this one here, pi over 3, is the same as the pi over 3 here. So there's need to factorize it. And here, that's where I factorize it. I said pi over 3, open bracket, then what remains is r squared and the big H minus r squared small h, but the data is here. 3 point, yeah, so from here I came here, that's why I'm taking you through so that you follow the order. From here I came here. So 3, I substituted pi, 3.142 over 3, open bracket, the big radius is 12 now. This is our 12 squared times the height is 22.5, this is one here, minus the small radius is 4. The small radius is squared, so 4 squared times the small height is here, which is 7.5. I just brought this thing down here with an open bracket, then 12 squared times 2.5, it gave me 3240, minus 16 times 4 squared, 16 times 7.5, it gave me 120. Then from there, I'm going to say 3.142 over 3, times, because this means multiplication, I subtracted that and it gave me 3120. And once I multiply 3.142 times 3120, then later divide by 3, it gave me that, which we can even round it off to 3270 cubic centimeter. And that is, oh, you cannot see, I just rounded it off. I just rounded it off to 3270 cubic centimeter. And that is how we can find the volume of a cone. That is how we can find the volume of a cone. Just one example is enough. If you are able to follow it up in a nice way, just one example, I can assure you, just one example is enough for you to understand. So now, away from that, I'm now going to do another example, which is now the volume of a prism, the volume of a prism. This was the volume of a cone. Now, let me see how I can find the volume of a prism. Okay, so finding the volume of a prism is not something difficult. It's the same. The concept is the same. All you need to do is just understand the formula, do the right substitution, and then compute them. You are good to go, which is as simple as 1 plus 1. So this one, I may not go to the sliced one, and maybe because of time, but I can just maybe give an introduction of it, the introduction point of it. Then tomorrow or the other day, I can come and solve one of the examination questions. Now, the shape of the prism, which determines its name, like I said, it may be different. You can have a base which is a set, which is a rectangle, then that would be called a rectangular prism. If the base is a triangle, we're going to call it a triangular prism. Now, what does it look like? We're going to have a triangular base like that. Okay, this is a triangular base, a triangle, but in a twisted way. Then, if this is a top, meaning all the corners must go and join the top. This is a rectangular prism. Now, this rectangular prism, the base here is a rectangle, and you know that the dimension of the rectangle is the base and then the width Though at times here they use L, then here B. It depends on the way you want it to be. At times they say base, then width. At times they say length and width, or length, breadth. Okay, and then definitely from the top up to the center of this, there must be an H. So how do you find the volume? It's the same thing. Volume is equal to base area 10 times height. Base area times height. But what is the shape of the base? It's a rectangle. How do you find the area of the rectangle? Multiply the length and the breadth. So we're going to say it's the length times the breadth times the height. That is how you can find the that's how you can find the volume of a prism. So if by any means these dimensions were given, we'll just look at example, a quick one. If these dimensions were given, most of the times when I'm making my own questions, I ask students to create their own, just to say numbers at random. So randomly, I'll pick 8 here, 8 centimeter. Here, I'll pick 6 centimeter. And here, let me use now, I've used the 12. Let me use 13 centimeters. So this is 13 here. 13 centimeter, 8 centimeter, 6 centimeter. But now, remember the breast that we have here is not the same even on top. So because of that, you divide by 3. Like though we did for a cone, the same thing that's done here. Now, if this is the question that you're given, it's simple. Just substitute the values. The length is 8 centimeter by the breadth 6 centimeter by the height, which is 13 centimeter. Then later on, you divide by 3. But you know that 3 can reduce 6 by 2. Then 2 times 8, that is going to be 16. 16 centimeter squared, then times 13 centimeter. So what will be the volume? The volume will be, I have my calculator here. So 16 by 13, that is 208. So the volume will be 208 centimeter cubed. That's how you can find the volume of a prism. Now, I think now I can look at the sliced one in a similar manner. If this thing was sliced, how can I slice it? Let me use a different color. If this thing was sliced, you can slice it like that. Yeah. You can also slide like this. Yeah. Then this goes there, and that perfect slicing. If that was the slicing which was done in that way, you find that the top part is removed. So how do you find the volume? It's the same thing that you used for a cone. You look at the view from one end. If you had to view it from here, if you are, so you need to do like I've done for a cone. Where's the marker? Oh no. Where is it now? Oh, here. So if you are to cut it in that way, we're going to have that. We're going to have that, which can also be viewed like this. It goes back to what extracted from a cone, where this is now, instead of it being now the radius and blah blah blah, here this thing will be our height, the capital H, then this will be a small h, this can be a small l, and this is the big L. And then you'll find that you start substituting, then the small volume minus the big volume minus smaller volume gives you the volume of the remaining figure. And that's how we can play around them. Okay, so let me see if we can pick on one, just one. Which one can we look at here now? Okay, the one that came in 2018. 2018. Yeah, just that one. The one that came in 2018, I think will be our last example. Just pay attention to this. You see how it is done. Then the other one you can find time to replay this video, and then you get to understand better. You get again to solve the one that is there in the paper. Like I had said, I'm not going to write the whole question on the board. The only thing that I'll do is the only thing that I'm going to do here is to the only thing I'm going to do here is to indicate the year in which it came. So the question came in 2018. Remember the subject code. The subject code is so it's 40 21 02 2018. Is this internal GCE? This is just internal. Internal. So that's the question that we're going to look at. 4021 02 2018 internal. How is the question? The question is a little bit hard to draw, especially if you didn't do the GMD, but like me, I did a little bit of it. So drawing, I think, cannot be a big issue. But we're going to assume that these lines met at some point. We're going to assume that these lines met. So after taking that assumption, then I'm going to slice the top part. Once I slice the top part, once I did not draw well, especially the projection of this line. So if you can draw like that, so that this line comes to join here, yeah. So if this one goes up to that now, and then this one goes up to that one goes up to that, and that one goes up to that. Yeah, so this is the information that we're given. We're given that this part was not there because it was removed. But when drawing, I took an assumption that the thing was there. So this is what we're given. I don't know if it's making sense to you. So on top there, we have got the rectangle, even the base here is a rectangle, and then these lines join each other. So what do we have? What are the dimensions? We're saying the length is 14 centimeter. If you can pardon me, here is 8 centimeter. And the height of the saying, given that the height of the the first term is this thing here, is 11.4. So this is the 11.4. Now, allow me to make a correction on the projection that I had given from this. You are not going to slice it in the middle, because if you slice it in the middle, it's no longer going to be the length. So we just view it from one edge. We are going to have something like that. We're going to have something like that, where this will be our small L, this will be our big L, this will be our big height, our big height, and this will be our small height. Yeah, so if you can allow me to take you, how do you find now this? The first question was a bit okay because they specified at first to say find the small height. In here, no height is asked, but you need to understand that the height is a stepping stone to volume. You cannot find the height if you don't know the volume. If you cannot find the volume, if you do not know the height. So what are you going to do? Similar shapes. So if this big triangle is similar to a smaller triangle, I'm going to say that the small L over big L must be small h over big H. Like I said earlier, the big height will be found by adding this, the small 11.4 plus the small height. It will be our big height. It's this one plus that. So we're going to say, what is our small L? Our small L is 8 over 14 equal to small h over big H is 11.4 plus height. Yeah. Now, let's try to substitute. We have substituted, let's try to compute for H. So once you multiply H times 14, you're going to have 14 H plus or equal to, so 8 times 11.4, 8 times 11.4, that is 91.2. 91.2 plus 8 times H, which is 88 H. And once you do that, okay, um, 14. Wait a minute, which one was provided first? Uh, okay, I think I messed out something. I messed out something. Just a minute. Just a minute here. So it's 14 minus 8, which is 6. Then 91.2. No. 91.2 divided by 6.2. Oh no. I think I made a mistake. I No, I'm damn right. I'm damn right. There's something that I was trying to overlook here. Yeah, so that's what we're going to do. We L small L over the big L small H over big H small. That's 8 over 14. 8 over 11.4 plus 8. So I cross multiplied 8 times 11.4 gave me 14H. Then 8 times H 80H. Then 14 here. So 8 14 times H 14H. 8 times 11.4 91.2. 8 times 8 times H 80H. So we're going to collect the like terms. We're going to say 14H minus 8H is equal to 91.2. Once you subtract 14 minus 8 gives us 6. So we're going to say 6H is equal to 91.2. Then we divide by 6 here. We also divide by 6 here so that our small h will be what is 91.2. Then divide by 6, it gives us 15.2. So this 15.2 is our small h. That 15.2 is our small h. It is just a simple process. Then how do you find the big H? It's 11.4 plus 15.2. So what will be the answer? So that answer is 11.4. So the answer will be 26.6 centimeter is the big H. The small h is 11, it's 15. The small h is 15.2. The small L is 8. The big L is 14. Then you just substitute. And how do you do your substitution? How do we do our substitution? We're going to say we're going to do the substitution. The substitution will be done in the same way we did for the volume of the cone. So we're going to say that the volume will be equal to volume 2 minus volume 1. But how do you find the volume? The volume is big L times big B times big H divided by 3 minus small l times small b times small h divided by 3. But the small big L is 14, small l 8. They are not the same. We can't factor them out. The big B is the base. The base. Did I state the base here? I think I did not write the base. The base here is 10, and then here is 4. Okay, so the big base is 10, the small base is 4. The small h is 15.2, the one that we just found. Then the big height is 15.2 plus 11.2, which is 11.4 plus 15.2, which is 26.6. So we are going to substitute. The only thing which is common is over 3. So 1 over 3, the length is 14, then times our breadth is 10, times our height is 26.6. We subtract the small l there now is 8 times the small b is 4 times the small height is 15.2. So that our answer of 1 over 3 is equal to, so let's try to find the value. 14 times 10 times 26.6 will give us 3724 minus 8 times 4 times 15.2 gives us 486.4. When we subtract this, we are going to have 3724 minus 486.4. We're going to have 3237.6, then divide by 3 there. The answer divided by 3. So the volume, you can see that the volume is equal to 1079.2 centimeter cubed. So that is how we can find the volume of. That's how we can find the volume of the 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 the, the sliced prism. I'll take you through again. View it from one angle, then get that figure. Use the similarity and congruent property to find the height. Once you find the height, then come and use the formula. In the cone, there were two things that were common: 1 over 3 and the pi. But in here, the length, the big L and the small l are not the same. Big B, a small b, not the same. Big H, small h, not the same. So the only thing that is common is 1 over 3. That is what you need to factor out. Then you substitute. 14 times 10 times 26.6 is 3724. Minus 8 times 4 times 15.2, and that was 486.4. When you subtract this, it gets you 3237.6. Then divide by 3, it gives you a volume which is 1079.2. But that can just be rounded